Alright, hello everyone. So I'm going to solve this approximate integration problem. So the question says, how large should we take simple n in order to guarantee that the Simpson's rule approximation for this integral is going to be accurate by this amount? Okay. Alright, so what's the meaning of this question again? Now you're going to integrate x to the 4 from 1 to 2. Right now actually you're going to approximate it using Simpson's rule. Now if you use an approximate integration method, you have to divide this big interval 1 to 2 into certain number of subintervals. So that number of subintervals is said to be n. Now you want this number of subintervals so that your error from the Simpson's rule method to be less than 0.0001. Okay, actually the number of subintervals affects to the error. Okay, so if you have large number of subintervals, the error is going to be small. Okay, so you want the number of subintervals that you will guarantee you this much accuracy. Now this has something to do with the error bound formulas. Now the error bound formula for Simpson's rule is going to be, let's write it, is k times b minus a to the 5 divided by 180 n square. Now what's the meaning of this error bound formula? So what we have here, what I'm highlighting from red color, is the worst case scenario, the worst error, the largest error that you can get if you use Simpson's rule. Okay, for certain number of subinterval n. Okay, so if you use n number of subintervals, you're gonna get but this is going to be your largest error. So now what I'm gonna do is, if my largest error, think about this, if my largest error is actually strictly less than 0.0001, if I have my largest error to be less than 0.0001, then my real error is definitely going to be less than this amount, right? Because if the largest error is less than 0.001, of course your real error is less than largest error, then that means your real error is less than 0.001. Okay, so you want to find n such that it satisfies this little scenario. Okay, all right, so let me rewrite that. K times b minus a to the 5 divided by 180 n square. You want that to be less than 0.001. Now k, b, a, we already know those stuff. So k, well actually we have to find it, right? We know how to find it. So f is, the function is x to the 4. For Simpson's rule, the definition for k is the bound for the fourth derivative, absolute value of fourth derivative of the function. So let's find the fourth derivative. First derivative is 4x cubed. Second derivative is, if you differentiate once more, it's 12x square. If you differentiate 3 times, it's 24x. If you differentiate another time to get the fourth derivative, it's 24. Now absolute value of 24 is 24. Actually 24 is actually the k value, right? That's the number value that we get. Okay, so let's put that here. So 24 times b is the upper bound of the integral, limit of the integral 2, and a is 1, that's the lower bound. So 2 minus 1 to the 5 divided by 180 n square. N we don't know, that's what we want to find. Right, so 2 minus 1 is 1, so it's 24 over 180 n square. Now what I'm going to do is, I'm going to take 0.001 to the left and n square to the right of the inequality. Both of them are positive values, so the inequality side doesn't change. So if you divide by 0.0001, this is going to be 0.018. Now I'm not going to cancel out anything or simplify anything, because I just need to take the square root of the left hand side. Okay, square root is going to be positive because n can be only positive, because that's the number of subintervals. Now I'm going to use a calculator. Okay, so if I use a calculator, what I'm going to get here is, I'm going to get 36.5. Okay, so if the number of subintervals larger than 36.5, your error from the Simpson's rule method is guaranteed to be less than 0.001. 0.0001. Okay, all right, now n has to be an integer, right? I mean, the number of subintervals cannot be a decimal. So the largest integer is the next integer is 37, right? Because n has to be greater than 36.5, but 37 doesn't work here because Simpson's rule says, if you're using Simpson's rule, n has to be even. We learned that when we were learning Simpson's rule, and we learned why then, okay, in that video. Now n has to be even. So 37 is not the best choice. 38 is the next best choice. Remember, n has to be larger than 36.5. You cannot choose 36, okay? All right, 36 is less than 36.5. So the next largest even integer is 38. So if you use 38 subintervals, you're guaranteed to have an error, actual error, or an accuracy of 0.0001. Accuracy less than accuracy of 0.0001. That's a tricky word, accuracy. Error less than 0.0001. Okay, all right, so that's how you solve a problem like that.